Why do people go bald?
Why are baboons' bums red?
What's a light year? Why do leaves go brown in the autumn? Why do monkeys like bananas? Why do some things glow in the dark? Why do animals not understand you? Why do my receipts fade after a year?
Don't know the answer? Ask the Naked Scientists.
Hello, welcome to this week's edition of Ask the Naked Scientists with Chris Smith and with me, Matt Jamison.
Did you read the story of Aesop's Fables?
I read some of Aesop's Fables, yeah.
Do you remember the story about the crow that dropped stones into water in order to raise the water level up so he could have a drink?
Yes, I do. I remember that one, and I remember the one about the boy who cried wolf as well.
Well, the amazing thing about Aesop's Fables is that they're actually more than 2,000 years old. That's where they come from. But there's a bit of research that was published this week that seems to suggest that, in fact, they're not fables at all. They're based on fact rather than fiction. There's a paper which has been published in the journal Current Biology this week, and ironically it's by a guy called Christopher Bird, who's at Cambridge University, and another chap called Nathan Emery, who's at Queen Mary University of London. And the two of them have recruited 4 rooks, those obviously members of the crow family. Mm-hmm. They've given them some exciting names: Cook, Fry, Connolly and Monroe, the rooks' names, and they got them to take part in some science experiments. What they did was to recreate one of those experiments that Aesop effectively wrote about. They offered these rooks some tubes which had water in them, and floating on the surface of the water was a tasty treat. It was a worm, and these birds were peckish. Ba-boom. And what the idea was to see if the birds could work out how to get the worm out of the tube. It was an upright cylinder, but the water level was such that the worm was floating below the level at which they could reach in and get it. So what the researchers also did was to offer the birds a collection of stones next door to the tube. And they'd never been taught to do this. They'd never been shown this happening. But they very quickly cottoned on to the fact that if they picked up stones and dropped them in, the water level went up, and they could then grab the worm. That was the first amazing finding. The second amazing finding was that when they presented them with a mixture of stones, big ones and small ones, the birds realised that if they just stuck to the big stones, A, the water level went up much more for each stone because it was bigger, and B, they had to do less work to shift the big stones in, because if they did the small stones, they would be there all day, so they got their reward quicker if they used the big stones. So they learned to do that very quickly. And the third thing they did was to see whether it was just generic bird-type behaviour. They were putting stones in a tube, or whether they could suss out what the difference was they were making by putting the stones in. So they presented them with a tube full of sawdust and a worm, which of course won't be affected by dropping stones in, and the birds very quickly realised that actually dropping stones into the sawdust didn't make any difference to the level of the worm, and they abandoned that and went back to the water.
Does this mean we have to go through every single Aesop's fable in this scientific way to try and find out if they're all true?
Well, I hope not, because the fox who wanted to grab hold of the grapes was, of course, part of the same story, and I haven't seen anyone investigating that yet. But I mean, this is incredible, because what it shows is that these birds, which have been dubbed by some scientists as feathered Einsteins, really are incredible in terms of their reasoning ability. They're very small, really. Their brains are not huge, but they have a very clever ability to interpret the situation and then work out how to use the tools at their command and apply them in order to solve a problem. And they're not actually known for using tools in nature, rooks. This was really the first time that this behaviour has been shown. But it's pretty incredible, isn't it?
It's always a good job you're here, because I'd never have these answers. Dave in Galston is our first listener question this evening. Good evening, Dave.
Good evening.
Thanks for holding for us. You're through
No
to
problem.
Dr. Chris.
Hello there.
Hey, Dave.
I'd like to know why we see pictures from the space shuttle, and we're led to believe that they experience weightlessness so high above the Earth's gravity, yet we're told that the moon affects our tides and so forth. So does it adversely our Earth's gravity affect the moon? How can their gravity affect our tides and so forth?
Hello, Dave.
Hello.
The answer is that they're not experiencing gravity. When astronauts are up in space, they are still subject to gravity. It may be slightly less than the gravity they would experience at the Earth's surface, because gravity follows what's called an inverse square law. What that means is that it reduces, or it varies, according to 1 over the distance squared. So in other words, if I double the distance to something, then actually the amount of gravity I feel at double the distance is 1 over 2 squared, 1 over 4. It's a quarter. So gravity decays away as a function of the distance squared, but it doesn't go away completely. So those astronauts will still be feeling a force pulling them towards the Earth. But the point is that they're actually being pulled towards the Earth all the time, and as they go around the Earth in their orbit, they're in what's called a state of perpetual free fall. They're always falling towards the Earth, but they're never quite getting towards the Earth because they're continuously moving in a circle. And what that means is that they feel weightless because the rocket that's carrying them is also falling towards the Earth at the same rate that they are. So it's a bit like you when your car goes over a humpback bridge and the car takes off a bit and you take off a bit and you feel temporarily weightless. They're like that all the time. It's not that they're not being pulled by gravity. They are, because if they weren't being pulled by gravity, they would go in a straight line and they disappear into outer space. But they don't. They stay in orbit, just like a satellite, because gravity's pulling on them. Gravity holds the Earth's moon in orbit around us. In fact, the moon is escaping from the Earth at about 2 centimetres or 3 centimetres every single year. It gets slightly further away from the Earth, and the moon is pulling back on the Earth. That's why we have tides. In fact, we have 2 tides a day because the moon pulls the water on the Earth's surface towards it and makes a tidal bulge on the surface of the Earth closest to the moon.
If you apply that theory to the moon, sort of like what you've just applied to the astronauts, wouldn't that sort of be very, very so weak that, the distance as well, would it affect our planet at all, you know? This is what I can't understand. How can their sort of atmosphere, and like when we see like these pictures where there's virtually weightless, you know, when the astronauts on the moon, there's very, very little gravity there, and in any case, so like if you apply that theory, what you've just sort of quoted, to the moon, how can that affect our tides such a distance away and so prolifically, sort of thing?
Well, the moon is quite close to us. It's 250,000 miles to the moon, and it is quite large, which means that it's still able to provide a fairly big attraction to the Earth's surface. And so you do get water moving in response to the moon. We know that because when the moon and the sun line up, you get a spring tide, and when they don't line up, you get a neap tide. So we know the moon is definitely making a difference to Earth's tides.
And the sun's as well, are you saying?
Yeah, I mean, the fact is that the reason we're in orbit with all our other planetary neighbours is because the sun's gravity is hanging on to us all. Thank God it is, or we would be living a very cold, dark life by now because we'd have disappeared off into space. But luckily, the sun's gravity hangs on to us. So it's all down to how big you are, and gravity's all about mass. And an astronaut who's hopping around on the surface of the moon doesn't weigh very much, therefore it doesn't have very much of an attraction between the astronaut, his body on the moon. The moon is pulling on him, but he's not making the moon move very much. The Earth, on the other hand, is very big, and the Earth is, and the moon is very big, and the two of them therefore attract each other quite well.
Dave, thanks for your question. We hope that's answered it for you. And our next question comes in from Les in Over, who says, just to add to your bit about rocks, I can't be sure whether it was a rook or a crow, but I was at the fish and chip shop in Bar Hill and saw this crow. It had picked up the bag, lining a bin near the fish shop, and was treading on it and pulling it until it got to the level where it could get to the chips at the bottom. I guess that's the same sort of thing, Dr. Chris? Or a similar sort of thing?
There's a researcher who's based in Cambridge who works on scrub jays, which are a member of the same family. She's called Nikki Clayton. We've had her on the Naked Scientist, actually, and she works on this kind of thing. And she's been able to show that these birds also do intriguing things like plan for the future. She did this wonderful experiment where she put these birds in a sort of bird house. It was like a bird hotel. And there was one room where they always got fed and one room where they always had to spend the night. And what she found was that the birds would take food from the area where they always got fed, and they would hide it in the room where they knew they were going to be spending the night, because they knew that they inevitably got locked in the room where they were going to spend the night, and therefore if they wanted to have a midnight feast, they better sequester some food there. And what this is showing is these birds are using past experience to plan for a future eventuality, which is pretty amazing. But one of the other stories she recounted was that she'd heard of examples of people reporting crows and other members of this family flying to bins. I think in the example she gave, it was a motorway services, and the birds would descend on a bin, and one bird would stand on one side of the bin, one on the other, and they would, between them, hoik up the bin bag, stand on it, the bit they just lifted, and then hoik up the next bit. And because there was two of them doing it, this lifted the entire bin bag up, so then a third bird could get in and get the rubbish out, and the third bird would go into the bin and chuck out all of the goodies in the bin, and then everyone would have a communal feast on the ground afterwards. I mean, I think these birds are incredible.
Has there ever been a question you can't answer, Dr. Chris? I don't
Yes,
think
this
there
one.
has. This one. It's
know.
coming from Gerald, our friend of the show, whose daughter Yasmin has just turned 13 and tells him she's starting her terrific teens. He wants to know, why is it that children in their teens become stroppy, argumentative, can't get up in the morning and can't get to sleep at night? That comes in from Gerald. Over to you, Doctor.
The answer is that the brain, as we grow, undergoes enormous amounts of changes and remodelling, as it's known. The brain cells that make up different bits of the brain connect themselves together differently. Pathways through the brain are honed and refined, some are cut, some are strengthened, and so all this flux is going on, and at the same time there's enormous amounts of other physical development going on. So you go into puberty, lots of hormones get released during puberty, lots of things like testosterone and estrogen get very high levels in the bloodstream, and these have onward effects in the nervous system. And people have done various bits of research on humans as they go through puberty. There's one bit of research which was done showing that if you ask children to look at pictures of faces, and specifically if you just take the strip of the face, including the eyes, so if you could imagine sort of having a slit through a piece of paper and laying that over a face so you could just see the eyes and a bit of the face around it, when you show those kinds of pictures to youngsters up until about the age of 10 and say to them, what mood do you think this person is? Give us some words that you think best describe the feelings or emotion of the person whose picture you're looking at. They do very well. But when you do the same test on kids in the throes of puberty, they do worse than an 8-year-old does. And then once they go through puberty and they get to about 17, 18, a bit older in boys, slightly less old in girls, they get that ability to be empathic and to understand again. So clearly, hormones are playing a very big role in how the brain works out, makes us conscious and makes us aware of other people and makes us empathic. There was also a study that got done by a lady in New York. Her name's Cheryl Smith. She's at State University of New York. This was about 2 years ago she did this study. And she showed that there's a hormone called allopregnanolone, which is produced during puberty. And what this normally does in an adult's brain is it increases the receptiveness or the sensitivity of the nervous system to a chemical called GABA. Gamma-aminobutyric acid, and this is an inhibitory neurotransmitter, so it dampens down brain activity, it calms you down. But during pregnancy, what she found is that this same hormone that normally has a calming effect has an exciting effect, so it boosts teenagers' excitability, and this means that you're more likely to fly off the handle rather than react calmly to something, and so it's all down to hormones. So I think a lot of this is the brain basically working out how to adapt very quickly to the demands being placed on it by a changing body, by a changing social and peer group, and having to embrace both of those changes and learn how to fit into this new body. And of course, it's a hard and demanding time. And you've also got other demands being placed on you, work and school and that kind of thing. So all these things stress the system a bit and make people feel anxious.
Is puberty the biggest change our bodies go through in the smallest amount of time? Because obviously as we get older we develop, but that takes more time, doesn't it?
Yeah, I think it's fair to say that the time when you go into puberty, that age about 12, 13 for boys, between 10 and 11 for girls, it's getting younger actually. It used to be a bit older. About 100 years ago, it was routine for girls not to start menstruating until they're about 15. Nowadays, most girls have been there, done that by the time they're 15.
How does that happen then?
Well, we think part of it's down to better nutrition and body mass. In recent years, in trying to discover what makes people get fat, for example, scientists have discovered a number of signals that are released by fat cells. One of them is called leptin, named after the Greek word leptos, meaning thin. And the fat cells produce this hormone, and this signals the brain as to how much body mass you've got. So it's the way in which your brain regulates your feeding behaviour. It could also, though, regulate when your body decides to go into puberty. And we know this is true because if women become too thin, the first thing that happens if they go below about 15% body mass is that they stop actually menstruating. So in other words, their fertility switches off. And this is a protective thing. If you're starving yourself, you don't want to get pregnant because you couldn't nourish a baby properly and it might harm your own health. So this is a very clever way of the body saying we don't want a girl to become capable of getting pregnant until she reaches a sufficiently big body mass, because then she would be healthy enough to get pregnant. So it's a clever way of tailoring when you want to get into potentially child-rearing years and tethering that to how big you are. And because people are better nourished, they're healthier, they have fewer intercurrent diseases, you don't catch stuff which dampens down and stunts your growth and so on. Because of all those things, girls are getting to the threshold age and weight sooner at a younger age, and as a result they go into puberty a bit sooner. That's the present theory.
Now, just before we go on to the next question there, you mentioned brain warming. That doesn't strike me as something that's particularly good. And your brain warms by 1%.
1 degree.
Well, 1 degree. If you're taking the mobile phone out of the equation and using something like a Bluetooth, does that reduce or level out that brain warm, or is it still going to be warm no matter what's near your ear?
Scientists have been forced to examine this quite carefully because of people becoming, justifiably I think, concerned that the widespread proliferation of mobile phone use could have health consequences. So this was examined on a number of occasions. There was one big report, the Stewart report, a number of years ago, where they looked at many, many users of mobile phones and health outcomes, and they couldn't find any strong and compelling evidence to link mobile phone use to adverse health outcomes. Specifically, people are interested in things like cancers. They're worried that there might be a link with, say, cancer and mobile phone use. There's no evidence for that at the moment when people use phones a reasonable amount. But one thing that they were able to show is that there probably is a warming effect, because when microwaves go through things, they're quite strongly absorbed by water, and your brain has the consistency of blancmange. If you pick up a piece of brain, it's very squodgy because it's full of water. And so the brain does absorb a certain amount of microwave energy, and therefore areas of the brain where the microwaves are focused may experience a bit of warming, because when microwaves heat things in your kitchen, what's effectively happening is that a microwave, is bouncing backwards and forwards across the inside of the microwave, and water molecules, because they are shaped like miniature boomerangs, with the oxygen in the middle a bit minus and the hydrogen on the arms a bit positive, the water molecules get flipped backwards and forwards as the microwave zips backwards and forwards at the same rate as the microwave, and it's that vibration that warms up the food. The same thing can go on in your brain. The difference is that when you put your food in your microwave oven in the kitchen, that's a kilowatt, but your mobile phone is not a kilowatt, so it's much lower energy. Therefore, the warming effect is much more subtle, and probably is not going to be a serious health issue, because when you go and sprint and do a heavy workout down the gym, then brain temperature does increase a little bit anyway through use and through increased body temperature. So the likelihood is that it's not actually going to be deleterious to your health.
That's good. Thank you for that. Tony's on the line with a question. Good evening, Tony.
Good evening, sir.
You're through to Dr. Chris.
Right. It's just a thing that occurred to me that our problems with wars and immigration, everything racist, colour, is an animal reaction, whereas, animals all hate each other. Well, not all of them, but you know what I mean. Dogs and cats, for example. Is it, do you think, an animal reaction from the past?
Yes, I do. And there was actually a very nice study which got done in the light of the last set of Olympics, to not this set but the set just before, so the 2004 Olympics. And what scientists there found was that when they compared the success rates of people who were doing Greco-Roman wrestling, they found that the competitor who played in red won far more often than the competitor who played in blue. And you can see the same relationships happening on the football field and in lots of other different games. People who play in red seem to do better than people who play in other colours. And probably the reason for that is that we're programmed neurologically to see red as a sign of danger. So when you're on the receiving end of someone who is very red in the face, red with anger, red with fury, you can see all of these similes coming up and metaphors coming up in everyday life. We use them without even realising why we're saying them. This puts the person who is on the receiving end of that at a psychological disadvantage. You tend to feel like you are faced by someone who is very, very powerful, because testosterone, the male hormone that revs you up and makes you big and bulky and strong and powerful, also tends to make you look a bit red in the face. So therefore, it's a sort of indirect sign of a testosterone-loaded individual, I would say. And so for that reason, I think probably a lot of this does come down to instinct. So I've just given you one example of how colour can affect our behaviour. We also know, as a social animal, we are a social animal. We form groups, we have language, we talk to each other. This also is very cohesive, and we look out for our neighbours, we defend them, and for that reason anything that could therefore be viewed as foreign, we therefore view with scepticism. We tend to be wary of it because historically, if someone turned up and they weren't from your group, your tribe, they might steal your food. And so as a result, I think we're programmed to want to be prejudiced against each other, people we don't know. We're sort of scared of strangers. We have stranger danger sort of signals going on. I think that's in our nature, and we have to unlearn that behaviour for today's modern world. But in the past, it served us very well. So we're just victims of our evolution, really, aren't we?
Well, Mike has a question that goes a bit like this. I have a self-winding automatic wristwatch that gains a minute every 3 days. However, after a long-haul flight, the watch keeps a perfect time for a week or so. Is this the effect of gravity? If it is, what's it doing to my body?
I don't think it is the effect of gravity. I've got a watch like that, and it loses about a minute an hour. It's terrible. I'm not sure why the long-haul flight should make a difference to it, apart from the fact that perhaps it doesn't get agitated very much on the long-haul flight because you spend most of that sitting down, staying still. Whereas when you're going about on your usual business, you'll be moving a lot, and this will be agitating the watch, and this may be winding up the spring more, because the way self-winding watches work is that they have a set of weights inside them, which, when you move your arm around, swings the weights backwards and forwards against a ratchet, which gently notches up a spring, which basically stores the energy you put into the watch as a winding in the spring, and that's how they then work. Well, if you keep the spring really tightly wound, in a cheaper watch, sometimes what can happen is that the extra tension in the spring can drive the watch machinery a little bit harder, which it means it gains time, or it doesn't run to time. But when you leave the watch to run properly across the entire run of the spring, so it winds up fully and then almost unwinds fully, that means that actually probably it will gain a bit of time when it's running close to the spring being fully wound, but then it will lose a bit of time towards the end of the spring unwinding, and when you average the thing out, it keeps perfect time. So that could be what's going on. It's the lack of movement on the long-haul flight which did it.
Ah, I see.
But I'm guessing. I mean, if anyone knows better, do tell me.
Yes, indeed, absolutely, of course. Ray in Felixstowe has been on the phone wondering, people always say with diabetes you should lose weight to avoid it. Is this the same with other illnesses? He gives an example. He was put on a drastic diet and lost 3 stone. Since he lost that weight, he hasn't had a single epileptic fit after having 300 in 1 year.
Gosh. I'm glad he feels better. Well, the answer is that losing a bit of weight if you're too heavy is always a good thing, because not only are you at risk of diabetes and what's called impaired glucose tolerance if you have too much body mass, but you're also at increased risk of a number of things, because when you carry too much fat, you also have a higher risk of high blood pressure. You also tend to have higher cholesterol, what's called type 4 hypercholesterolemia, which is bad for you, and both of those things can be linked to heart attacks and strokes. So just by slimming down a bit, then inevitably you can reduce your risk of what amounts to one of the leading sets of killers in this country, and in fact across the Western world. So losing weight is a good thing. Why this should have translated into fewer epileptic seizures, I'm not entirely sure. It's possible, I suppose, that if there is a metabolic problem that was leading to the high amounts of weight, that perhaps getting the weight right then made the metabolic problem a bit better, because we know that when people don't have enough glucose or good control of their glucose, this can trigger off things like fits. But I'm very pleased to hear that there's been a good outcome there.
That's it for this week. Thanks for listening. Remember, you can send The Naked Scientists your questions by email. chris@thenakedscientists.com is the address to write to. And if you want to find out more about The Naked Scientists, then drop by our website, nakedscientists.com.
The Naked Scientists are sponsored by the Wellcome Trust, the EPSRC and UK Fast. For more information, look us up online at nakedscientists.com.